Hello students, I am Pratima. I welcome you all to this video. So today we are solving some MCQ questions from real numbers with some concepts also. So let us begin without wasting time, and you have to remember certain result for doing well. First is Euclid division lemma. Given two positive integers a and b, there exists a unique integer q and r satisfying a is equal to bq plus r, where r is greater than equal to 0 and less than equal to b. This is very important concept because sometimes this itself comes as a objective question. Second is Euclid division algorithm to obtain HCF of two positive numbers c and d, where c is greater than d. It is taken as, this is the steps. First is c is equal to dq plus r, where r is greater than equal to 0, less than d. If r is 0, d is itself a HCF of c and d. If r is not equal to 0, then apply the division lemma to d and r. Continue this process till the remainder is 0. The divisor at this stage will be the required HCF. Next is fundamental theorem of arithmetic. Every composite numbers, that means which is not a prime number, can be expressed as a product of primes, and this expression is unique apart from the order in which the prime factor occurs. Next is p is a prime number. If p divides a square, p divides a, where a is a positive integer. Next is square root 2, square root 3, square root 5 are all irrational numbers. Next is the sum of or difference of a rational and in irrational is always a irrational number. The product of or quotient of non-zero rational number and irrational number is always irrational number. And for any two positive integers a and b, HCF of a and b multiplies LCM of a and b is always product of a and b. Similarly, next is let x is equal to p by q. P and q are co-prime. Be a rational number whose decimal expansion terminates. That means this is about terminating decimals. Then the prime factorization of q is in the form of 2 to the power m multiplies 5 to the power n, where m and n are non-negative integers. That means if denominator has the factor 2 and 5, then it will be terminating. And if it has other than 2 and 5, it will be non-terminating. Last, if p by q is a rational number such that prime factorization of q is not in the form 2 raised to the m and 5 raised to the n, m and n are being non-negative integers, then x has a non-terminating repeating decimal expansion. That means if it is 1 upon 10 or 2 upon 10, 3 upon 10, it is a terminating. But if it is 2 by 15, that means here the factors are 3 and 5, it is non-terminating. So let us come to an example. MCQ questions. The decimal expansion of rational number 33 by 2 raised to the power 2 into 5 will terminate after 1 decimal place, 2 decimal place, 3 decimal place, and 4 decimal places. So let us see the denominator. When it will be in a simplest form, it is 2 multiplies 2 multiplies 5. That means there are 2 as a factor 2 times. So when you will make into a decimal, you need 10 2 times in the denominator. 10 2 times in the denominator means it will be 100. So it will this rational number will be terminating after 2 decimal places, because you need another 5 years, or you have to see how many 10 can be possible. So it will be terminate after 2 decimal places. Now sample question 2. Euclid's division lemma states that for two positive integers a and b, there exist unique integer q and r such that b a is equal to bq plus r, where r satisfies the condition. This is just as the lemma stated directly. So you have to remember it should be r should be greater than equal to 0 and less than b. So what will the answer? C is answer. Now coming to questions. MCQ question. You know the sample question. Choose the correct answer from the given 4 options given in following questions. For some integer m, every even integer is of the form m, m plus 1, 2m, 2m plus 1. So any integer m, we need the even integers. We know that even integer is always multiple of 2. So twice m will be the answer. C is answer in this question. Question number 2. For some integer q, every odd integer is in the form of. Odd integer means it will be even successor of even. So successor, if it is any number q, it's twice always a even. And even plus successor or even plus 1 is always a odd number. So D is answer of this question. Next is question number 3. N square minus 1 is divisible by 8 if n is an integer, a natural number, an odd number, and even integer. So n square minus 1 is divisible by 8. So we can test by starting from 1. 1 square minus 1, 0. It is divisible by 8. But if I take 2 square minus 1, it will be 3. It is not divisible by 8. So natural number cannot be the answer. Now any integer cannot be the answer because 2 is not here. Then coming to odd number. Odd number 1, it is true. Now coming to next odd number is 3. So 3 square minus 1 is equal to 9 minus 8, 8. 8 is divisible by 8. Similar, next is 5. 5 square minus 1 is equal to 24. So 24 divisible by 8. So it will be a odd integer. C is answer. Question number 4. If HCF of 65 and 117 is expressible in the form of 6x minus 117, the value of m is 4, 2, 1, 3. So let us find what is the HCF of 65 and 117. You know it is 13. 13 5 times and 13 9 times. So 13 is HCF. So I can write 65m minus 117 is equal to 13, or 65m is equal to 130. 117 I shifted to right side, or m is equal to 130 divided by 65. The answer is 2. So which one is correct? B is correct answer. Question number 5. The largest number which divides 70 and 125 leaves the remainder 5 and 8 respectively. What is the largest number? It is 13, 875, 65 and 1750. So how to do this question? First you take 70 minus the remainder, it will be 65. Then you take 125 minus the remainder, it will be 117. Now find the largest number. Largest number means you know that is HCF. So 65, 117 HCF we have already found out. It is 13. 13 5 times, 13 9 times. HCF is 13. So A is answer of this question. Next is question number 6. If two positive integers a and b are written as a is equal to x cube y square, b is equal to xy cube, x and y are prime numbers, then HCF of a, b. One is your x cube y square and one is xy cube. So what is the HCF? HCF is, you will take the minimum power of x. So it will be x, then take minimum power of y, that will be y square. So x y square is the answer. So try to identify where is the answer. A is xy, not is the answer. B is xy square, so B is answer. Question number 7, it is a similar question. Question is to find the LCM if two positive integers p and q can be expressed as p is equal to ab square, q is equal to aqb, ab being prime numbers, LCM of pq is. So p is equal to ab square, q is equal to aqb. As I told in the earlier question, so minimum power is taken as HCF. So for LCM we take the maximum power. So a and a cube, the maximum power is a cube. And for your b and b square, the maximum power is b square. So a cube b square is LCM. So C is answer of this question, because a is ab, b is a square b square, c is a cube b square, and d is a cube b cube. Now coming to question number 8. The product of non-zero rational and a irrational number is always, it was given in the concept, it is always irrational, always rational, rational or irrational, maybe anything, or 1. If it is a zero rational, then it will get 0, which is rational number. If it is a non-zero rational, then the product will be always irrational. So A is answer of this question. Now coming to question number 9. The least number that is divisible by all the numbers from 1 to 10, both inclusive means 1 and 10 will be included, is 10, 100, 504 and 2520. That means you have to find least number, means you know it is LCM. Least number is 1 to 10. So you have to find the LCM of 1 to 10. LCM 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 2, 3, 4, 9, 5. Then you will go for again 2, 5, 3, 7, 2, 9, 5. Then you will go for 3, 1, 1, 5, 1, 7, 2, 3, 5. And you are getting again another 5. So what will be 5? 1 here, then 1. So what will the LCM? 2 into 2 into 3 into 5 into 1, 1, 7, 2, 3. 7 into 2 into 3. So 2 to 4, 3 are 12, 60, C 120, 360 into 70. So it will be 2520 is the answer. D is the answer. 10, 100, 504, 250. 10. The decimal expansion of rational number 14587 by 1250 will terminate after 1 decimal place, 2 decimal place, 3 decimal places and 4 decimal places. I am just rubbing, getting some places to do. In between, you can also get it because we have already done it. So first what you have to do, you have to find the factorization of 1250. You have to see how many 2's and how many 5's are there and how much 10 can be possible. So 1250, if we'll find the factor, it will be 5, 25, 250, 5, 50, 5, 10, 2, 5, 2. So there are 4, 5 and 1, 2. That means it can be made into 4 10. So it will be terminate after 4 decimal places. 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal places will be the answer.